Hello friends, from today's question, block A of mass m and block B of mass 2m are placed on fixed triangular wedge by means of a massless inextensible string and a frictionless pulley as shown in figure. The wedge is inclined at 45 degree to the horizontal on the both sides. The coefficient of friction between block A and the wedge is 2 by 3 and between block B and the wedge is 1 by 3. If the system of A and B is released from rest, find the acceleration of A, the tension in the string, the magnitude of friction, and direction of force of friction acting on A. So this is a figure. We have two blocks A and B connected with the string. The mass of A is m, of B is 2m, and the angle of inclination of the wedge is 45 degree. So first of all, let's draw the various forces which will be acting on these two blocks. Okay. So this is the triangular wedge. We have block A and we have block B. So in the downward direction we are going to have, let us suppose that is MAG, and it can be divided into two components. This angle will be theta, so we are going to have this MAG cos of theta, and this will be MAG sin of theta, and there will be a normal, let us call that normal as NA, and the string attention T. Similarly for block B as well, the downward direction we have MBG divided in two components. This will be angle theta. Let us suppose this is theta, which is obviously 45 degree. So we have MBG sin of theta and MBG cos of theta, and there is tension T. Okay. In this case, the mass of B is given as 2m and it is given as m. So let us consider that block B is moving in the downward direction and block A is moving in upward direction. Block B is moving down the inclined plane and block A is moving up the inclined plane. So we can find out the net force. So here it will be normal also and B state. So first of all, let's find out, as they are connected with a string like this, so the net force which will be acting on the entire system. Okay. You can say the net force acting on the system, and we are mainly interested in the forces which are along the inclined plane. Okay. In system along the inclined plane. So let us call that as F net. So we can say that our F net will be equal to MBG sine of theta minus meg sine of theta. Substitute the value, we get this as 2m g sine of 45 minus mg sine of 45 sorry. So this can be written as sine of 45 is 1 by root 2, so we get f net as will be equal to mg divided by root 2. So this is net force which will be acting on the block, and it will be along the inclined plane towards the B. Okay. Now let us find out the various frictional forces. So first of all, the frictional force for block A. Frictional force for block A. Block A is moving up the inclined plane, we have said. So the frictional force will be acting down the inclined plane. Let us call that FRA. And there is a normal, that is NA. And there is a force which is along the normal but in opposite direction, that is MAG cos of theta. So from here we can say that our normal NA will be equal to MAG cos of theta, and we have this equal to mg cos of 45. So you can say that force of friction FRA will be equal to mu A multiplied by NA, and mu A is given as 2 by 3. So this will be 2 by 3 mg divided by root 2. So this will be the, and this is the maximum value of the friction. Okay, this is the maximum value of friction. So therefore we can write this as FRA max equal to FRA, and this is equal to 2 by 3 mg divided by root 2. Similarly, we are going to find for block B. Frictional force for block B, and block B is moving down the inclined plane. So we are going to have frictional force, let us call it FRB, in the upward direction, and we have a normal, that is NB, and in the opposite direction we are going to have MBG cos of theta. From here we can say that our NB is equal to MBG cos of theta, and which is equal to 2mg cos of 45. Therefore our FRB is equal to mu B NB, which is giving us, mu is given as 1 by 3. So this is 2mg divided by square root of 2. And this also is the maximum value of the friction. This is the maximum value of the friction. So we can say that FRB max will be equal to FRB, and this is equal to 2 by 3 root of 2 mg. Now we are going to find out that what will be the total force, frictional force rather. Okay, you can say total, therefore total frictional force, and from the figure you can clearly see that both the frictional forces are acting in the same direction. Okay, FRA is the down the inclined plane, FRB is up the inclined plane. So direction of both FRA and FRB is same. Okay, you can say here direction of FRA and FRB is same. Therefore we can say if the total friction force is FR total, then we can write FR total will be equal to FRA max plus FRB max. So if we add them, we get this as FRA max is 2 by 3 mg by root 2 plus it is 2 by 3 mg by root 2. So this comes equal to as FR total will be equal to 4 is equal to 4 divided by 3 root 2 mg. Now we are going to make a comparison between the net force and the frictional total force. And let us call this equation number 1 and this as equation number 2. So comparing equation 1 and 2, we can clearly say that the total value of the friction, that is FR total, is greater than F net force. So we can say F net is mg divided by square root of 2, and the value of F total is much larger as compared to F net. Okay. Therefore the system will be in equilibrium. Therefore system will be in equilibrium and let us find out for block B, we are going to find out the tension T. Okay, in the first part it was supposed to find out what will be the acceleration of A, okay, but the total force is greater than the net force, so the entire system will be in equilibrium, so the acceleration of A will be 0. Thus the acceleration of block A will be 0. Let's find out what will be the tension now for part B. So let us consider for tension block B. Considering block B, so block B, we have a tension T. In the downward direction we have mbg sine of theta, and also we have frictional force Fr. So as the system is in equilibrium, okay, so this block B will be also in equilibrium. Okay. Block B in equilibrium, you can write the equation as tension T plus FRB will be equal to mbg sine of theta. So from here we can find out our tension T. So we can say tension T will be equal to mbg sine of theta minus FRB, and we already know that mb is 2m, so this will be 2m sine of 45 square root of 2 minus FRB we already calculated, and that is 1 by 3 2mg divided by square root of 2. So from here we can say that our tension T will become equal to 4 by 3 mg by root 2. So this is the tension T. And in the last part we are supposed to find out magnitude of friction and direction of frictional force acting on A. So part C. So for block A, we already found out that the value of tension T is 4 by 3 mg by root 2. Okay, and block A is also in equilibrium. Okay, block A is also in equilibrium. So let us draw for block A. So this is block A. Upward is the tension T, and downward it is acting mag sine of theta. So down the inclined plane, the force acting is down the inclined plane, force acting is equal to mag sine of theta, and which will be equal to mg square root of 2. And from here we can say that our tension T, let us suppose call this as FA down. Now if you make a comparison between downward force for block A and tension T, you can clearly say that tension T is greater than FA down. Okay. T is greater than FA down. So therefore, the block will be having the tendency to move up the plane. Okay. Therefore, block A will have tendency to move up the inclined plane. Okay. And as it has tendency to move up the inclined plane, therefore the direction of frictional force will be down the inclined plane. Down the inclined plane. So let us draw the direction of friction. So this is block A. So we have here MAG sine of theta, FR, and the relative tension T. Okay. Now we already said that block A will be in equilibrium, so we can write that tension T will be equal to MAG sine of theta plus FR, and from here we can say that our FR will equal to tension T minus MAG sine of theta. Substituting the value, T is our 4 by 3 mg by root 2 minus we have mg divided by root 2. So this gives us FR, that is the force of friction, will be equal to, we can take mg by root 2 as common, so this will be, and getting this as mg by root 2. So this is the value of the friction which will be acting down the inclined plane, magnitude rather. So okay. Thank you.